Today I'll explain the general method behind solving the average matrix function. The average matrix function has four parameters: the in-array, two-dimensional dynamic array. The 2* stands for the two-dimensional dynamic array. The first asterisk points to the address of the first row, or the number of rows. So that first asterisk would point to the first row, the second row, or the third row. The second asterisk will point to the columns, so the first one, second one, third one, or fourth one. Them together would allow us to access the individual values of the matrix. The second parameter is int rows, which gives us a number of rows in the matrix, and with columns gives us a number of columns in the matrix. And then the double two-dimensional out array gives us our output array, which we would be filtering into. The problem also says that there's a minimum of 2 rows and a minimum of 2 columns, therefore saying that this is always going to be a 2-dimensional array. And then there's also at most 8 neighboring elements, therefore saying that it's either going to be a square or a rectangle. This is the function again. This is the matrix that we're going to be using for the purpose of explaining the general concept of this problem. So to solve this problem, we're going to need to access the neighboring values of each value. So the value I chose was 0.5. Now, since this is the corner value, there's going to be 3 neighboring values: 2.0, 1.5, and -1. To find the average, you would just do any arithmetic calculation, which is the addition of the sum of all 3 values divided by the number of values. So it would be 2.0 plus 1.5 minus 1 and divided by 3, because that's the number of values. And then for our out array, we would filter this 8.33 in for this value. So in our out array, it would be 0.833 in for this first value. You do the same process for all 4 corners. So find the 3 values neighboring them, and then find the average of those. Now for border values, there's going to be 5 values, but the process is the same. You find the sum of all 5 values divided by 5, and that 1.04 would replace that 2.0 in the out array. And you would do the same thing with all the border values. Now for the middle values, same process, but with 8 values. So you would add all the values up, divided by 8, and that 1.025 would be in the place of 1.5 in out array. And you would do the same process for the 2 values in the middle. This is the final output with all the averages found of out array. So this would be our output.